We're going to be looking at reduced radical form. And this is using the properties. So a little refresher on the exponent properties. Big title, sorry. If you have a to the power of m times b to the power of n, oh, sorry, let's change that to an a to the power of n. My bad. This is going to result in a to the power of m plus n. So you're adding those exponents. If you have a to the m to the power of n, this is going to be a to the power of m times n. Let's say that you have a to the power of m divided by a to the n. This is subtraction, so it's a to the power of m minus n. If you have a to the power of negative 1 over m, oh, sorry, I'm getting ahead of myself, negative m, then this is going to be 1 over a to the m. Because you're with the negative exponent, you're flipping that. And last but not least, if you were to have a b to the power of m, that m goes to the a and the b. Just a quick review of the properties of exponents. You should have already learned this in Algebra 1, but if not, just a quick refresher. So you're going to be using those properties of exponents in order to simplify stuff. And remember, when we're looking at exponents, exponents could be a radical if it's a fraction. So just think about that in terms of, you know, why are the exponents related to radicals? So looking at this, we're going to be talking about how to rewrite the expression. So let's say that we have 2a to the power of a third times ab, and the b is to the power of a half, and that is raised to the power of 2/3. So when I'm looking at this, I'm going to take care of kind of like order of operations, parentheses, exponents. So I'm going to work with that 2/3 first. Since it's on the outside of that parentheses, it goes to the a and the b. So I have 2a to the power of a third, in parentheses, a to the power of 2/3, b to the power, so it's on the outside, it's raised to another power, so we're going to multiply those exponents of a half and 2/3, which results in a third. Now I'm going to combine my a's here, and because they're being multiplied by each other, they're not raised to a power, we're going to add those exponents. So this is now 2a, well 1/3 plus 2/3 gives me 1, and then this b is going to be raised to the power of a third. If I'm rewriting this in radical form, I have 2a and then the cube root of b. This would result in my final answer. The other thing that we're going to be working with is how to reduce radical form if you have multiple radicals. So for instance, let's say that I have the square root of 20 plus 3 times the square root of 25 minus 6 times square root 45. Okay, so with all of these different radicals, you need to actually simplify them first. So the square root of 20 can break down into the square root of 4 and the square root of 5. The square root of 25 just breaks down to a regular 5. Square root of 45 breaks down into the square root of 9 and square root of 5, which ends up being a 3. So I'm going to rewrite this. I have 2 square root 5 plus 3 times 5 minus 6 times 3 square root 5. So when we're looking at this and trying to reduce this down, you can combine like terms. That square root 5 is going to be a like term. So this is going to result in that 6 times that 3 is going to get me to 18. That 15 is going to stay by itself because obviously it doesn't have a square root. So I'm going to deal with those square root 5s now. So just like if they were a variable, you're just going to combine them together. So my final answer is going to be 15 minus 16 square root 5. And then the last thing we need to talk about in order to reduce radical expressions is when we need to rationalize the denominator. The good thing is we have experience with this. So let's say that I have 3 over 4 minus square root 6. So similar to when we had complex numbers, we would multiply by the complex conjugate. Well, in this case, we're multiplying by just the regular conjugate. So you're switching the sign in front of that square root, and it gets multiplied to the numerator and the denominator. So looking at my numerator here, multiply that, distribute that 3. So I now have 12 plus 3 square root 6. In the denominator, I'm going to distribute that. So I'm going to have 16 plus 4 square root 6 minus 4 square root 6 minus the square root of 36. Lots of square roots. Well, if you notice here, the 4 square root 6 minus 4 square root 6, that actually cancels, which is nice. That's, the goal here. And that square root of 36 can go down to a regular 6. So we now can have no square root in that denominator. And that's great because you technically, by math terms, you cannot have a radical in the denominator. And this is why we rationalize that denominator. So my final answer here is going to be 12 plus 3 square root 6 over 10. And that's just rationalizing your denominator by multiplying by that conjugate. So there are different ways to reduce radical form depending on what you're working with, whether it's multiplication or if you're dealing with the exponents on how to reduce that stuff.